Hello everyone. Today we're going to start on by touching on our design first, and then we're going to go and talk a little bit about what I already did. I'm still getting the volumes to be okay so you guys can hear my voice over the music. So first off, let's start a little with this. Okay, this is my design document. I have all the data that I want, simple overview of gameplay, listing of disasters and how they're caused and what will they do, a mock-up of the interface. This is a simulation screen, which is going to be something I will do later on. I hope to do it. And then I have this part about politicians and how I will get how much money they will give us, because I want to have like this kind of political council. So it's very good to have this mapped out, and I mapped that thing over this Excel sheet, and you guys can see I have like 500 lines of simulations, and I got an average and everything. So this is a value that I deemed okay. Like I like this proportions to it, and we're going to start today on Unity. We don't need to install Playmaker again. Okay, on Unity, I already created some stuff. I added Amplify Shader, Playmaker. I added Procedural Toolkit, which is a free asset, by the way, really good, and all the standard assets. And I created a prefab folder that is empty and a script folder that has disasters, planet, and politics inside, but all of them are empty, as you guys can see. So what we're going to do is we're going to start planning on how we're going to actually work the game. And I'm thinking we should start by making the planet class, because it's one of the most complicated ones. And I want it to be very robust. So I want the planet class to have everything that we're going to use. So let me throw this on full screen, and we can start typing on it. And let me just do this. So I don't want to have a Mona behavior class, because we're not going to do it like that. We now need a void planet that's going to be empty. And I think what the planet class should have is a list of areas, planet area, called planet, and we now need to create this. So planet area, I'm thinking we have this big planet, which is going to be a list full of small chunks, and basically that stripe of data is our planet. So we want each small part to have some information on it, like height, I don't know, like if there's water, humidity, and all this kind of stuff, so we can control over that and then do simulations. So what we can do is we can go back here to Unity, and we're going to create another C# script called planet area. Go over there, open it up. Yeah, let's reload. And planet area is also not going to be like this, and it should have a string. Let's see. What are the things that we need? We need height. We need humidity. We need We need something to see if the soil is stable, because that's going to be something we're going to do on landslide. So soil stability, if there's population on that area, if there is food sources, nuclear, if it has like nuclear things on it, and we can start seeing like a pattern here that we're starting to basically check for stuff that we can destroy, which is not that cool, but that's the way it is. So tsunamis will be height, right? We need to see if it's high enough so the tsunami can pass through it. And then humidity is basically to see if rain happens, and also if fires will happen. And then soil stability is for landslides, and actually hurricane earthquakes too. Population is to check for damage. Food sources is to see if plagues and diseases, and if anything happens, what is the impact. Nuclear to see if we have nuclear waste problems, and I think that's good enough. So we can have public, float, height, public, float, humidity. There we go. Public, float. This shouldn't be a float. This should be an int population. Public, float, int food sources. And we can start creating some constraints here, right? Let's press enter here real quick. So this is height from the 0 level on the height from the 0 level ocean level. Let's make this ocean level. So positive means over the ocean, negative it means underwater. Humidity it should be a percentage, so a number between 1 and 0. So let's make this 1, meaning that the humidity is really high. Probably covered in water. And then we have the soil stability. I want soil stability to be a number between 0 and 100. Because I want more fine grained detail. And this means, let's say 100 means soil is very stable, not prominent to earthquakes or landslides. 0 means like like how is the soil there? So like it will shift a lot. Population is amount of people in the area. And food sources. Food sources is amount of food to feed one person in the area. So if I have 100 population and 100 food sources, no one's starving. If I have less than that, someone is starving. So That's basically what I want. And then we need a public bool nuclear if there is nuclear activity on the area. Also, we need to check if there are volcanoes, right? I don't think we're going to add a lot of volcanoes on our world. So volcanoes are basically, they're interesting because I'm thinking of representing them like when deciding if there are volcanoes or not. I'm kind of like, yeah, let's see if like soil stability is not high, then we can like add a volcano. Humidity is not high, we can add a volcano there. But I'd rather have this like that. And now we already have a lot of variables, right? So these are all stuff that we're going to control. So I'm going to create a nice area data so we can start controlling our stuff and knowing what's happening where. We don't need this. So this does enough though. I'm thinking, how should we create the word later on then? I'm thinking, what if we start by creating like the tectonic plates and then populating on top of them, and where they meet we add volcanoes. That might be a good idea. Let's start writing some stuff about word generation. So the word is a list of areas that have properties to them. Oh, I wrote that wrong. Properties to them. The simulation should go over all the areas and then decide what happens. Actually, let me think, because we need to know what is going to happen, right? So either we can directly create probabilities variables on each area and then roll for them each turn, and that's probably going to be a big problem. Or we can just create a lot of parameters and those will influence the probability of other stuff. I think that's a better approach. So you can see here, and then decide what happens. What happens based on the properties of the area. The creation of the word should take in account some parameters that will limit very chaotic places. So we should give a maximum number of volcanoes and such, or should take into account some parameters that will limit actually some parameters that will help on deciding factors on all the areas. So let's say when we create a planet, we give a number of tectonic plates, and then this will influence how big they are and where are the common fault points and volcanoes. So usually we're going to have this strip, and let's say we have 5 tectonics, so we'll split them 5 times, not symmetric, that's important. And then we'll say, okay, where they join, add volcanoes, so volcano, and then between them we can say that the borders are more fragile, so we do borders, and then we simulate for less the top. Or we can start with the middle and then go away from the middle, and we can like spend a number of soil stability. I think these variables are good. We can for now delete this, and let's create some initializers. So void planet area, sorry, it's public planet area. I'm going to do this because there are a lot of stuff that we're going to cover, and I want to type all the variables names again. So height should be if we give an empty, I don't think we're going to ever use an empty one, so let's just make float humidity height. Let's make the first 2 letters. Float soil int population int food sources bow nuclear bow volcano. So height equals this equals food, soil equals PO equals food equals nuclear equals volcano. So now we actually created the word. Let me think. We're going to need some functions to determine if we can should we return a disaster, or should we let's create some like is ocean, actually is water, if the area is underwater If the area is underwater. Meaning it is an ocean or a lake on. Actually, meaning if it's an ocean, so we can call it is ocean. Because we're not going to have the idea of a lake in the middle of it. Turn height bigger than 0. True. So if height is bigger than 0, this will return true. If not, it will return false. So that's commentary here. True if the area is underwater. False otherwise. Let's make a public bow. Actually, let's make a public float earthquake chance. And this will return based on soil stability, we will need to add another variable, public distance to tectonic. This is an end because it's just the amount of tiles. To So this is going to return distance multiply by soil stability. I'm going to make this 1. That's going to be a percentage. And then we can change this, of course. So now we have the planet area. So you can have a list of planet areas called planet equals new list. Okay, and void, actually public planet. Planet needs to have some properties, so tectonic count. How many tectonic plates are there? Also public int size. How many areas are there in the planet? Okay, so we passed this. So int t. I'm going to pass size first. And when you do this, is we do like for int I you can have public. No, we can have a array list. No, we can have an integer of tectonic edges equal new int of t, right? First, we just have to set this. I think we should do the creation on another function. There you go. So instead of t, we do tectonic count. And we do I minus tectonic add tectonic count. This is okay. I plus plus, and we do I don't know how will we sort this? We need to get like 5 random numbers. I don't know. So we should have int tectonic counter equals 0, and we'll do this like that. So while tectonic counter is less than tectonic count, tectonic edges we can take this out. We don't need to say where the tectonic plates are. We can simply tell that the distance is 0. So if 0, then this is a tectonic join point, right? So we will create, so planet dot add no, we need to do it differently. Let's see. We will do a for, because fors are good. Int I equals 0. I less than size I plus plus. That means we're going to fill the list. So what we're going to do is planet.add new planet area, and we have to put all those parameters. So first, height, so a random range. We need it to be from minus something to 100. Let's say these are the. We can make it better. We can make a public float max height, public float mean height. And we can say max and mean area heights. And we can do this. And here we can make mean height. And here we can make max height. Not random range, just random dot range. That's better. Okay. So now humidity. So we can let's do this. We can do better. Since we're creating this function already, let's do this. No. Random dot range. Humidity. Humidity can go from 0 to 1. So let's make this height, humidity. After humidity, we have soil stability. So another random range 0, 1. Soil stability. Population. So this is a problem. I'm not sure how I would go around this. We need to think about how we're going to do this map creation in a way that it won't be like really bad and won't be just like random numbers around there. What if first we create a height map, right? And then we start adding stuff. So now we can create a random height. Can we show a list? Could we create a bar graph out of this? Like I'm going to delete this, and also I'm going to do this debug.log. Is there a way for me to see lists as graphs? I'm going to see the asset store because that's probably list view framework. I'm going to download this. I'm going to use it to actually see the list. This good part about Unity, like really one of the parts I really like is there's 100% chance that someone already had your problem and is looking at it. I mean, wait. I could have created this like no problem at all. Like just a way to like scale cubes. You know, we'll scale a lot of cubes, like add them all to 0 and then scale them. Like I could have created that. I should have. Now usually like importing stuff is not that simple. It's simple, but like, let's see. List view data. Okay, I'm going to create that. I'm going to not have this, right? And I'm going to create another function called public populate cubes. It's a void function, so my bad. And I'm going to do the same thing. I'm going to game object cube equals new primitive. Okay. Cube dot yeah, we have to do game object dot create primitive as for a primitive type dot. Okay, let's make a cube. And does it take position? No. What is the problem? Okay. Let's do something else. I'm going to create another script called planet. Don't do that. Creator. There you go. And that's going to be this. Yes. We're going to do planet Earth equal planet. Oh, yeah, it needs It needs arguments such as size and max height, min height, weight. There you go. So now I can create stuff. So it's size, let's make 100. TE is number of tectonic plates, I'll make 5. No matter. Max height, let's make 100. Min height, let's make minus 100. Should I swap this? No, that's okay. So we're going to do earth dot create, and then for int ei equals 0, I'm less than earth dot size I plus plus. Okay, I'm going to make this list public. And then I'm going to do game object cube equals new game object dot create primitive type dot cube. Okay, why are you not recognizing create primitive? Okay, I shouldn't use new. There you go. So now cube, cube dot dot local scale. X is going to be 1. Y is going to be earth dot planet I dot height and 1 on Z. I forgot to create a vector tree, so there we go. Now we have the height, and now we need to make a cube dot transform dot within position. Sorry. This needs to be 1 multiplied by I. So each cube will tile to the side. And no errors. Very good. Let's create an empty object and drag planet creator there. And this is going to be planet creator. And if we run, okay, we can pause this and we can zoom. And here we are. I'm going to do this a little bit better. I'm going to make cube dot set dot transform dot set parent this dot transform, so that way everything is a son of planet creator. Here, and you can see also the position should be this. Should it? I think so. Let's try. No, definitely no. Let's make this math.abs. So yeah, now we're getting absolute of half the height. Okay, there we go. This is how our planet looks right now. It's not very pretty. So we can start. See, this is a good thing. We can start tweaking. So like this is really small. But this is a planet. So what if we had 50 minus 10? That would make most stuff be up on our scale, but we would still have very low parts. Like this is definitely not good enough. But what we can do is we can pass a function here that's going to be public void smooth, and our this function should, okay, let's see, create all planet areas with designated height. Here we're smooth all planet areas relative to their neighbors. So what we're going to do is, for 0 to size minus 2, and we can let's create a function here that's going to be set height. So public void set height, and this is going to take a float height, and it's going to call height equals he. Okay, there we go. So what we're going to do is planet I dot set height, and we can make math f okay, what does this move? Like Unity mathf smooth. Let's see, what does that function do? No, that was not what we want. We're going to create the good old method. So first here, let's set I to 1, and then we can create this, like planet I minus 1 dot height plus planet I dot height plus planet I plus 1 dot height, and we're going to divide all that by 3 and save. This is a simple average, and so every time we call this, we're going to move 1 to the side. So we're going to like pop it down or pop it up or whatever. So what I'm going to call here, we're going to smooth it first. So earth smooth. Actually, public. No, not that. I'm going to create a public flow. Okay, int smooth amount equals 1, and for I equals 0 to smooth amount I plus plus earth smooth. This is good. So we go back here, clear. Our planet creator has now a smooth. Come on, where are you? Save it all. There you go, smooth amount. So if you play it once, this is a smooth amount. Like if you make it like a big number, it should be more uniform. There you go. So it's already looking more like a planet, right? Not that much, but a little. See, okay, now we have some curved surfaces, but we still need to fix the first and the last. So let's make this like that. Planet 1, planet X, planet 0 dot set height is equal. Can make this like that. Is actual equal planet 0 plus planet 1 dot height divided by 2. And then we can go here and wait a second. What if I smoothed around like the list? I went to the end and then smoothed thinking about the first. I could do that. So I don't remember how I will go like mod length. Like I think it's I have this list circular axis. So if I'm on the end, let's see here, a circular reference. I think it's mod, right? If I do a mod, so like if this is like that, this is like this, and I make all of these numbers mod size. I'm going to do this. Actually, I doesn't need it, but this one needs it. How would that work? Okay. We already have an error. Argument is out of range. So our index is out of range. So let's say we have mod, right? So mod operator does like 10 mod 5. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. No, not like that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. No. So array color. So how would we go and get the mod? I don't remember the exact operation. Okay, I think this is size -1, if I'm correct. Nope. Okay, I'm going to do two variables like int a equals I -1, int b equals I +1, and that way we can manipulate them here. So it's AIB, right? And A equals A mod size. I'm going to debug log A. And I'm going to copy this for B. Don't know why I put an N there, but there you go. Okay, -1. See, here's a problem. So what is -1 mod 5? It's 4. It should work. This is really weird. I should be having our stuff like correctly. Is size the problem? I think size is the problem. So -1, -1. You can try this. Okay, B is quote-unquote correct for 0, but A is not. So like if I have an array of like 50, right, 100, I should have 100 here, and I should have generated 100, because 0 to 100 is like 0 to 99 is 100. Should I be opening this like that? I just don't see why is the problem. First two, 0 and 2. So when I'm first, I'm going to, when I'm 1, I'm going 0, 1. That's correct. And then 1, 3, and let's see the last ones. It's 100, so the 99 is accessing 98 and 0, which is correct. Should I not start at 1? That's really strange, but okay. Okay, this move is working, kind of. If we play, we should see our smooth thing go. And what if we now add more complexity to this, like 100 minus 100. So stuff should be more chaotic, technically. Okay. I think minus 50 would be enough. So we have a lot of progression up, not that much down. And what if instead of 100 we have 200? It's doing this thing that I don't like selecting the bot like this. It's always tileable, which is okay. And like this is a perfect map. This is kind of okay. I should make because it doesn't matter how high they are, how height they are. They're going to be like that, so what if I made 100 and 0? Everything would be greater than 0. Because the way I'm doing with this absolutes thing here, it's kind of dumb. If I have it like this, I should see a lot of like negatives. No, actually, I'm still running that. So I should see a lot of areas under the horizon. Yeah, like these are oceans. Everything else is land, which looks really weird. And now we have a lot of oceans and almost no land. So let's make this a little less than that. 100 and minus 20. Okay, now we almost don't have, like, I think we should just set the max height. Don't have min height, and min height will always be 0. That way we can set how high we want this, and it will work itself out for we can work on the ocean level later. Yeah, this is good. This is definitely good. This is good. This is good. I like this. Yeah, we have this move thing now. We would still need to break the planet into tectonic plates. Our smooth algorithm is in the best. We're just like this average. There you go. It's not the best solution. It's going to make a lot of these curvy things. We can see here, like if I make zero smoothness, this is how it looks. If I add 10, this is how it looks, which is not bad, mind you. This is really not bad. And we can see, like, this is actually interesting. We can. The good thing, I didn't know how I would go on to do simulations. The good thing about doing like this is now I can see a simulation happening. Like, this makes sense. So I'm going to save this, and I'm going to save as scripts planet. I'm going to make planet test, just because I don't want to save it as a full scene, because it's not going to be a scene in the game. It's just me testing whatevers. I'm going to take a quick break, and then I'll be right back. Thank you for watching.